Okay, we're up.
Okay.
Thanks, Lance. Okay, so today, my presentation today will really just be covering off on some WoodSolutions, the Mid-Rise Advisory Program, and what we do, and I'll just add a few more comments to what Lawrence has already introduced to you. Well, to put that in context of today's presentation, and then some case studies at the end. So further to Lawrence's introduction, as he said, we offer a free and independent, non-commercial support to design and build professionals for timber projects of 4 or more stories. As Lawrence said, we have a number of resources, so I won't go through all of those, but I would urge you to go to the website. For instance, we have a series of technical design guidelines. These are incredibly informative and will really add value to your projects. And as he said, we have training and CPD presentations, expert advice and support. I will touch on the fact that we're funded through an Australian government under a voluntary matching program, which means we have our supporters, our partners, as we call them, and I'll move to that slide now. So you'll see here our funding partners, and I won't run through the list, but they support the program, and then the government, through the government levy, they match it dollar for dollar. We're also really proud to advise that as of 1 January next year, we have another partner who's joined the program, and that is Sumitomo. So we are thrilled to have them on board. One of our free services that's really, really invaluable for those who are in Melbourne or visiting Melbourne now that we're not as restricted as we were, is our guided tours of our mid-rise demonstration model house at the Holmes Glen Institute in Chadstone, Victoria. Design and construction support, demonstrating which timber systems might be used to achieve success on your project. So it's a really interesting building that you can walk through and understand all the different types of technical construction that you can use. So putting it in context, so there's been a number of stimulus packages announced by governments across Australia, and I think we'll see more of that coming out over the next 12 months as we come out of COVID. As we all know, Victoria announced $5.4 billion for a mix of housing, new dwellings, and a serious amount of that will go to social housing. So that's through Melbourne and regional areas. New South Wales announced $812 million. That announcement included 400 million fast-tracking housing construction packages, delivering something around 1,300, I think it is, social homes, $200 million to upgrade 3,500 existing homes. There has been criticism in the media that perhaps it's not enough, perhaps some of it was announced before, but I think just watch this space to see what New South Wales continues to offer in terms of stimulus packages. In Queensland, partnering with Build to Rent developers to deliver affordable housing, there are 2 projects that we're aware of secured as of 3rd of October 2020. This was also, and WA announced $319 million in June 2020 as part of the WA Housing Strategy 2020 to 2030. This was also announced in October 2020, and that includes the refurbishment of 1,500 homes, maintenance of 3,800 homes, and construction or purchase of another 250 dwellings. In South Australia, in October, they announced ongoing consultation to modernise the state's social housing system, and approximately $550 million was announced in 2019, but we haven't seen anything new for 2020. Now, this is a part of a report, or just a couple of comments from AHURI. And AHURI, for those who may not be aware, is the Australian Housing and Urban Research Institute. They do a series, and I declare I am on the board of AHURI, and they have done a lot of research this year based around COVID, and I know that there is a massive volume of reports coming out next, so I suggest you just keep an eye on their website and have a look at their reports as well. So this report found that much of the public housing stock was built in the 50s and 60s, and therefore it was designed to accommodate working families in 3-bedroom houses. And in 1981, 56% of public housing stock was actually 3-bedroom houses. By 2017, this stock is reaching the end of its asset life and maintenance costs are becoming excessive. These actually rose by 30% in the period 2001 to 2006, and that was double the rate of the previous 5 years. So we've obviously got a problem with aging stock. As well, with public housing now focused on housing those with greatest needs rather than low-income working families, the stock is really not fit for purpose for today's tenants, who are more likely to be single-person households. This is also a chart from the Uhuru report, and this shows you that 57% of housing is in fact for single-person households. Public housing is also underutilised by 16%. That was in 2016. And social housing households have at least one member with a disability. So that's 1 out of 3. And I think with an ageing demographic, we're going to see that rise as well. Just moving on, this is very Melbourne centric, but that just talks about population growth. The reason I've moved on from that probably a little bit faster is that given we're coming out of COVID and the restrictions on movement with immigration, I think those figures will be revised. What I did hear recently is that this year, though, has seen, this won't impact social housing, although the trickle-down effect may, but there's been something around the figure of 580,000 expats returning to Australia, and a number of those won't go back overseas. So there will be higher demand on housing in Australia, and that will obviously have a trickle effect down to affordable housing and then impact social housing. And there's an initiative by the federal government to actually attract talent to Australia, and I know they're targeting IT, they're targeting the major universities, the Ivy League universities around the world, to attract talent into Australia. So that will take a long time, but there will be a flow-on effect to housing across Australia. The case studies. So we have a few case studies here. The first one is in Preston, and this was completed for Victoria's DHHS, delivering high-quality 1 and 2 bedroom apartments. The location of this was fabulous because it was really close to transport services, health services, and employment opportunities. As you can see on the screen, there are 68 apartments across 2 buildings. They're built in lightweight timber and framing throughout. The next one's an international example. So this is Stud House, also known as Murray Grove. So this is the first high-density housing timber project in the world. Murray Grove is an award-winning project located in central London. It features 3 floors of housing trust social housing, with the remainder of the building held by private owners, and apparently that's around 50% each. It's a perfect precedent of social housing recently championed in Victoria, and the integration of housing type works to reduce the stigma of social housing within a high quality indoor and environmentally sustainable environment. So if you haven't looked at this one, I would urge you to jump online and have a look at it, or speak to our team further about that. That is it from me. So I will now hand over to Dean.
Thank you, Jennifer, and thank you, Lawrence, for the introduction. Good morning, everybody, and yeah, my name is Dean Ashton. I'm also with the Midrise team. I'm based in Brisbane. Today I'm actually working from home, but the building that you can see over my shoulder is 25 King Street, which is Australia's tallest timber office building, and I'm fortunate enough to have an office in that particular building. I come from the lightweight timber framing background, and I'm a structural engineer. So my focus today is more on the structural design of these buildings and the opportunities for the social housing in that market. So if I get into the next slide. So what I'll talk about first off is the products and the systems, what timber products can be used. We'll talk briefly about the design for cost-efficient buildings, and then I'll touch on the prefabrication in line with the lightweight timber framing. So when it comes to timber, we're talking about all types of timber products. There's sawn timber that's used for plates and studs, trusses and joists, LVL, laminated veneer lumber, where there's very thin laminates that are glued together to make larger sections, glue laminated timber or glue lam or GLT, and then the flavour of the month at the moment is the cross-laminated timber. But when we're talking about these particular products, they fall into two different categories. The sawn timber, the joists and trusses, LVL and GLT, if the minimum dimension is less than 75 millimetres, that's what we're talking about when we're talking lightweight timber. Now, LVL, glulam and CLT can also fall into the massive timber, and that's when the minimum dimension is greater than 75 millimetres. Now, timber has been used for housing for many years. So with the sawn timbers, the LVLs, glulams and I-beams, extensively used. But what we're talking about when we're getting into mid-rise projects, we're talking about what's been used in single-storey, two-storey housing. You know, that sort of developed into three-storey housing. Then it moved into townhouse type situations. And we're using those same sort of principles. All we're doing is going a little bit taller. With the townhouse type situation in the middle here, you need to have a dividing wall which is fire rated and acoustically rated. When we're getting into mid-rise, you've got vertical and horizontal separations, and Palo will talk a little bit more about the deemed to satisfy requirements in his presentation next. But also with the lightweight timber framing, as I said before, prefabricated roof trusses, they've been used extensively in Australia for over 50 years now. We've got prefabricated wall frames, floor trusses or floor joists, so there's different ways of framing up the floor. And I'll come back and talk a little bit more about some of the innovations in prefabrication at the end. When it comes to designing for cost-efficient buildings, as I said, I'm focusing today on the lightweight timber framing side. These are a couple of photos out of the US. But typically, as we go taller in a building, we're using the same sort of principles, but just that in the upper levels, we try to optimize it. So the upper levels might be like a single-story, two-story house. As we move down through the building, we start to increase the timber grade or the timber size, or we start to use the studs and everything at closer spacings. So we try to optimize so we don't just have the same design all the way up through the building to make it cost effective. Oops, I skipped over a slide there. As an example of this is not a social housing project, but it goes to show what can be done with lightweight timber framing. So this is the Oxford project at Williams Landing in Melbourne. So we've got I think it was 48 apartments in a 5-story building there, all done out of lightweight timber framing. So it was built by Figurehead and the architects were DKO. But when we're looking at optimizing our designs, if we look at first off the floors system here, we basically want to try to optimize the designs by keeping our spans around about the 3 to 6 meters. Now that makes it quite competitive with a concrete floor system. We can go bigger than that. It just means that the sections the floor depth will need to be deeper, and it may make the building a little bit higher. We try to avoid transfers, and by that I mean we line up load-bearing walls or columns so they're above each other. We don't want to have a load-bearing wall landing in the middle of the floor. When we do that, we start needing beams, and that adds a bit more complexity to it. And also typically floors, we want to have a one-way floor action, meaning that the floor joist system will span between load-bearing walls or load-bearing beams. So we try to keep the floor system as simple as possible. And again, if we go back to that Oxford approach, this was, as an engineer, I look at the top level and work my way down. So at level 3, we used just our load-bearing walls between the apartments. We had a 5.4 metre span. As we go down one level, go down to level 2, you'll basically see it's duplicated. It's exactly the same layout. We go down to level 1, again, exactly the same layout, just that now we're starting to have some extra veranda areas down below. So this really falls into that optimizing so that the spans, we've got a 5.4 metre span. It lands in that 3 to 6 metre range. We don't have load transfers. The load-bearing walls are landing over the top of each other. So we're getting transfers vertically through the building, not through the floor system. And it's a simple design. It's the same layout all the way through from the upper levels down below. When we look at the walls, Again, we try to optimize our design. So as I said before, as we go down lower in a building, we might have to increase the stud size. So we go from MGP10 to MGP12 or to LVL. We might have to go larger in size. We might have to, instead of using a 90 by 35 or a 90 by 45, we might even have to go up to a 140 mil on a taller building. But in this particular project, that falls within that area. Lightweight timber framing typically can be used from 3 to 6 stories. As I said, in America, they've been using 6-story construction lightweight timber framing for many years now. When we're talking about CLT buildings, it's great for any buildings that are 3 stories or above, or it can be used for smaller buildings, but typically what we're talking about today, I'm talking about anyway, is the lightweight framing system. So in that 3 to 6 stories is ideal. And we prefer to want to span the walls as being load bearing between the apartments. If we've got internal load bearing walls, we then need to have extra fire rating on those internal load bearing walls. So if we can try to just span between the apartments, that'll minimize any fireproofing and fire grade plasterboard that would be required. So again, on this particular project, the height, it was 4 or 5 stories, so it lands in that 3 to 6 stories for lightweight timber framing. Stud sizes, there were standard type stud sizes that are used on residential type construction, and we've used our load bearing walls as the interparty wall, so we've minimized on the amount of fire rated plasterboard that was required. Lawrence mentioned at the start that at WoodSolutions we've got great resources. This is one of the technical design guides. There's over 50 that you can download free of charge from the WoodSolutions website. And in this one here, it goes through the various timber construction methods. So we're mainly talking about the light frame option, but you can see other types of construction that can be used. So it's a great resource that you can download. So just going back to the prefabrication, as I said, timber roof trusses, prefabricated, nar-plated type trusses have been used in Australia for over 50 years, as well as floor trusses and prefabricated wall frames. What we're starting to see now is a lot more panelisation in the factory. So the first of that was starting to look at floor cassettes or roof cassettes, where these are put together in the factory, delivered to site, and then lifted up. So this really speeds up the construction on site and increases the site safety. You don't have workers walking around on unsafe platforms. Everything's nicely installed. And what we're starting to see a lot more now is the wall frame systems are being panelised as well. So either partially enclosed, so just the typical wall frame lined with a bracing type system, or you can get the fully enclosed systems where all of the plasterboard, even windows and doors, are fully installed in the factory and then just lifted up to site. Again, this really increases the site safety, and these buildings can go together without the need of scaffolding. So again, reducing costs, increasing the speed of construction, and making it safer for everyone. Whoops. So we just see some panels there that have been delivered to site, ready to be lifted into place. We're also starting to see prefabricated facade systems. So we're going to be hearing more about this project, Rock Commons, over in Canada next week. But we can see there that this was an 18-story building, student accommodation building, where there was, again, no need for scaffolding. These were lifted into place, and that provided the site safety. And this was at the ANU University in Canberra. Again, the panelised facade just lifted into place. So thank you, everybody, and I'll now hand over to Paolo.
Thank you very much, Dean and Jennifer, and to all of you listening. So I'm talking about what is a growing trend in Australia, the use of mid-rise timber structures. Okay, I need to use the rolling part of the mouse. So as you can see from these photographs, there is already a number of mid-rise buildings which don't look like a timber building, but they are, both for hotels, for student accommodation, offices, residential, and everything. So you may ask yourself why, and you might ask yourself how when you see the way that these buildings have been built. The photos here are the naked version of the previous photographs. So as far as the why, the main reason is that there is a series of typical efficiencies and cost benefits which are demonstrated in a various degree for different projects. So every project is different. So in some projects, maybe the differential value is maximized, or the safety, or the fast delivery, or the decrease in preliminaries. But typically, all of these 6 criteria, to a certain extent, are combined, are always present to provide their synergistic effect. And as we as WoodSolutions are a fact-based company, we are always providing data, evidence, even photos, examples of projects that we receive from others. So we remain independent, and we remain linked to evidence-based. As to the how, in the last 4 years, since 2016, when the deemed to satisfy provisions were approved for timber structures to be used up to 25-meter effective height, we started our mid-rise advisory service. And we did a lot of seminars, of presentation, of third-party events, site visits, etc. So a lot of activity, but especially a lot of project-related meetings, discussing with you that are online now and many of your colleagues, your projects. So before COVID, we projected what had happened until 2019. We had up to 25 projects active or completed at the end of 2019, and we expected a 20–30% growth into the coming years. Then COVID struck. Now it's difficult for everyone to make any forecast, but of course we can see that with much less people on site for the same surface of the platform of the live deck, and with much easier prefabrication like Dean showed, there is really room for making engineered wood products even more attractive for now on. And the first reason why we provide our support to development and design teams is to explain how the performance solution works, how the deemed to satisfy provision works through a series of guides, and also some documents like the fire engineering reports, which can be used by both the fire engineers and the building surveyors that we did provide, that we did organize with Exova, and that we provide free for everybody to download on our website. They are not specific to any project, but these tests were the basis, and evaluation were the basis for the code change. So we offered them to everyone. Then we have an interesting guide on fire precautions during the construction of large buildings. This is very, very popular with the fire engineers, site managers. And so I welcome everyone to have a look and ask us if you want any further information. It is being updated, by the way, currently. So there will be soon an updated version. And then we have an ongoing collaboration with the AFAC, which is the national authority about fire services, on how they can improve also on their existing and quite interesting guide for the design of mass timber building systems. So in terms of practical provisions, the requirements for a construction detail to be deemed to satisfy is that in the building, there are automatic sprinkler systems. This not just for timber, for every material into the mid-rise space. Now it's mandatory to have automatic sprinkler systems, that the fire protected structural wood is present, and I will show you what it is. Also, Dean showed it a little bit. That when there are cavities, there is no combustible insulation into these cavities, and cavity barriers were applicable. Our guys 37, the series for residential, commercial, and now we have one specially dedicated for hospitals and aged care, which is being released. And then another guide specific to aged care. You will find plenty of construction details. This is an example, just as an example, I pulled out the maximum FRL, which is feasible, and show you a couple of examples for internal and external walls and the floors and ceiling. Of course, this is 3 level or 4 levels of fire resistant plasterboard. If you drop down to 90 or 60, then you drop down the number of these layers, of course. But what's important is the way that the cavity barriers are installed, the way that the fire blocking is installed into light frame construction, for instance. So a few examples. This is an aged care building in Sydney. It was built with full deemed to satisfy concepts and detailing. As you can see, it's a traditional build with scaffolding, and it went very, very well, meeting all the aesthetical comfort and construction efficiency requirement of the clients, which is Mulfa, a major developer. This is a student accommodation in Bandura, so in Melbourne. The main result for the builder, which is Multiplex into this case, is that with respect to their typical construction schedules, which were very, very optimized for this type of building, just the year before they did that, Multiplex had delivered 1,500 beds in student accommodation to different clients. So they were very, very well optimized into their cycles with timber. This is the second project that they did in timber. They had an average 2 to 3 days quicker per floor than their concrete experience. As you can see, no scaffolding, a prefabricated curtain wall facade in aluminum in this case, went up very safely, very quickly. So apart from the boxed construction, which we have shown with respect to student accommodation, social housing, and residential in general, there are still the possibility to have open grid designs. And there are many opportunities which can be deemed to satisfy if, as I said, the structural timber components is fire protected. Okay, so for instance, the post and slab. This is something that not many people know it's possible now with the timber. That's an example. This is the 18-story student accommodation in Vancouver, Canada, that will be the object of our webinar next week. You can see the timber here during the construction. There's no beam, as you can see, so it's a fully post and slab. Everything was encapsulated, as you can see, into the final version before opening to the public. And this, according to the fire brigade in Vancouver, the head of fire brigade declared this is the safest building in town when it was open. So really, when it's properly designed, properly executed, it has a high level of fire safety indeed. That's another example in Ballarat. An office for the government, which is soon to be open, maybe in January or February it will be open. It's very, very well advanced. We supported the full design and construction team into this, designing, procuring, and organizing the fire testing, which provided evidence that what they designed for was fully achieved. But another very, very important aspect is designing and constructing for durability. And this is how can I say, a very evident example in Brisbane, a semi-tropical climate. This building was built in 1913, and it is the grandfather of the one where Dean has his office, which was built a couple of years ago. They differ in the modern use of the facade, but they have in common the timber structures, which are well designed, well executed, with no preservatives. They are able to be efficient into that climate. Our guide number 5 provides a lot of information about this. Anyway, you can always refer to us. We also have a lot of activity in advising how framing can be optimized. This is the typical example of a mid-rise building with, we take an apartment, study how it can be done in different ways. You see, we proposed in this case 7 alternatives. using the different materials in alternative ways as you go up, and costing the result for the different alternatives. So we are happy to provide you this type of advice when needed. We have a number of tools for the structural engineers, like this software, which was made available free for download through a R&D project, and our Guide 50, which has also 2 appendix with calculated examples. Then we have a number of other guides for the structural engineers for solving specific problems or integrating with acoustic, etc. And we have Guide 51, which Lawrence and myself authored together with Ryder Levitt Bucknell, because, as you know, all our guides have also either just an independent author or also an independent author together with us. So into this one, additionally to all the costing advice, we included some advice on how to optimize the construction, how to study and analyze the de-risking, the risk management, and really it's a very, very interesting set of indications. Then we have a very interesting R&D result about wellness and productivity, which are linked into office buildings, a topic which is of a high interest now that we are reopening our offices. And we have our environmental product declaration, free for download, and some evaluation based on how much the sustainable plantations grow in Australia, how much of that can be turned into engineered wood products, and how much this relates to the amount that is used in different buildings and the time for regrowing the amount of timber which was used into this building. So be assured that our engineered wood products are, for a long time ahead of us, fully sustainable. And in conclusion, the engineered wood products offer true and significant opportunities for value engineering and future-proofing your designs. As pragmatic people like insurance companies said in the UK, for instance, G&T organized a panel forum with 11 of them, the major insurers. 43 of the panelists agreed that by 2030, 50 to 75% of the new buildings will include some timber. So with this, I'm concluded, and we are looking forward to your questions.
Lovely. Thank you very much, Paolo. Thanks, Jennifer and Dean as well. So a couple of really interesting presentations, obviously looking at the current opportunity, I suppose, for social housing and how timber systems can be used to realise those opportunities. We've been fortunate. We've had quite a bit of interest in the questions section. I could see someone, I think Jennifer, you might have answered a couple in writing, which is a great start because we're going to be pushed to get through them all. If we don't get through these, then we can always update them on our website if need be. Of course, you can see the link down there at the bottom of the slide. There's a couple which have received upvotes, so I might start with those. The first one is asking about the capacity of the supply chain. Obviously, if we are looking at huge amounts of funding coming in, and obviously a very large number of projects, I think what was that, 12,000 in Victoria by 2024, that means there's going to be a lot of construction underway. Do we have the supply chain to supply these projects pretty securely? I don't know who would be best to answer that one, but maybe you can...
Look, my second last slide sort of started to answer this, associating to a 4 example of buildings, the amount of timber which was required into that building, and therefore the time for regrowing from our sustainable plantation resources. Recently, Jennifer and myself have met with a professor in Sydney. Sorry, I don't remember the name in this moment, but this professor from University of New South Wales he has done an interesting study calculating on the national level and projecting up to 2030, 2050, and probably even more different scenarios. Jennifer helped me into this, if you remember better than me. What will be the availability of our forest resources in terms of projected growth of use of timber structure. So what we can do, we can provide you with, if you're no more anonymous, then we can provide you with some information when we contact him again.
Yeah, beautiful. Yeah, anything to add to that, Jennifer? Or
no, I was actually flipping through my notebook. But the other thing that may come out of this is, you know, we're living in a different world now, and you know, there is always a discussion about the supply chain, but there's also opportunity in Australia for timber producers and then the manufacturers to actually, well, particularly the manufacturers as opposed to the timber producers, to upscale their investments in their factories, etc. So, you know, hopefully we'll see some changes and some innovation in that space as well as the industry responds to the demand.
Yeah, beautiful.
I'd just like to add as well, from the supply chain point of view, I think Jennifer made a note in the chat before to contact the MAP team early so that we can assist on the procurement side. We some of our partners are in the supply chain. Obviously, we have CLT suppliers, we have nail plate manufacturers. So if you're looking at the frame and truss sector, this sort of type of project is not going to suit every frame and truss sector fabricator, because they're more focused on lightweight, like residential type construction. But the nail plate manufacturers can certainly lead you to the suppliers who can do these sort of projects. So yeah, get in touch with us early, and we can put you in touch with other people. Yeah,
I think that's a really good point, especially when we're looking at a pipeline of projects of this scale. Sort of getting in early and getting suppliers in early as well as builders, and just getting everyone in the same room. I think that's required when you really have a expedited project program. The next question which we've got, which has received a couple of upvotes, is from a gentleman by the name of Mark Borovich. He's wondering if there are, I guess, similar to the supply chain, are there builders out there with experience in timber construction? Obviously, there's been a couple of precedents shown already, but maybe Dean, would you, could you run through a couple of those, or any sort of stellar ones that you think would be really suitable for social housing, multi-res?
Again, in the lightweight timber framing in the Melbourne market, depending on where you are, again, get in touch with us if you're from somewhere else. But in the Melbourne market, you've got Figurehead, the Murdoch are doing these sort of projects as well. And then, each of the states in South Australia, there's been a couple of very good projects. WA, there's been projects. So there's certainly
all around the country,
right around Australia, that can get involved in these projects.
Yeah, beautiful. Cool. All right, the next one is one from Jane Ribley, who, in response to your first, I suppose, your presentation, Jennifer, just saying that obviously, so the needs of social housing occupants have changed over time, of course, as you outlined, but that is something that's going to continue to evolve. In 50 years' time, it'll be different needs, no doubt, from residents. How does that work with timber construction? Maybe, Paolo, I know, knowing your background, that might be the best for you. Is it easy to retrofit or refurbish timber buildings, or what's your experience there?
Yeah, it is very easy, as you can imagine, because any intervention on timber produces less dust, less noise. It requires less energy. It's easier to do than in other materials. So definitely retrofitting a timber building requires the same attention as any other building in terms of structural engineering. So if you want to knock a wall, you need to put something in its place, a beam, or find a way to redistribute the loads. But certainly the way you operate and the speed and the disturbance that you have in doing it is much less than with other materials.
Yeah, beautiful. Yeah. And then I suppose it might be a little bit less likely, but along that sort of prefabrication, change of design, variation, I suppose, line of thought, if it is, not retrofitting, but before construction, is it possible to, vary designs a little bit? Often I know in multi-res construction, you might get a purchaser who wants to buy 2 apartments and connect them. Is that something that we can do readily with timber, or is it more problematic?
Yeah, no, it is easy. And this is also why I wanted to include in my presentation some examples of post and beam, post and slab, because now we are more and more often suggesting to architects and developers to consider using some of this, at least, into their designs to future-proof their building. Because everybody is interested in what happens in 20 years, how they can reconfigure, make 2 one-bedroom apartment into a 2 or 3 bedroom one in the future. So that's a way to future-proof your building. Distribute the load already from the beginning in a way which allows it to happen later on.
Yeah, that makes sense. We've got another one from Mark here, asking about the environmental impacts of building low to mid-rise timber buildings. He says he knows that CLT stores a lot of carbon, but what about lightweight framing? Which, I think is a good question, considering that we're generally looking at smaller section sizes. I don't know who'd be best to answer that. Would anyone like to take a stab?
Well, with the lightweight timber framing, you're not going to have the same volume of timber in that building, but the timber is still storing the carbon. It's there for the life of the structure, so you do have the benefits. As Paolo said, in his presentation, the growth rate of the trees, the trees grow back very quickly. So the environmental benefits are there from that side of it, but certainly from the carbon storage, less volume of timber, but still storing the carbon.
Yeah, and plus, it will have a little less storage, but also a little less foundation, a little strength transfer, because they are lighter even than CLT. So there are other advantages.
Yeah, it's a good point. And I would also point out, because I've been looking at this a bit
Better
recently as well. Sorry?
Better potential for better insulation because you have a cavity.
Yeah, true. And I guess less thermal conductivity as well in that building envelope,
exactly.
which is a good thing. I've also recently been looking into a couple of reports, which our sort of parent organisation, Forest and Wood Products Australia, commissioned quite a while ago for RMIT to generate a couple of life cycle analyses. Firstly on Forte, which was of course, the apartment building built in Docklands in 2012-13, but also on the Green, which is a 5-storey timber frame building in Parkville, which I didn't know that they did, but there's this wealth of information out there. And of course, both buildings saw quite a significant benefit to using timber from a life cycle point of view. So if anyone would like more information about those, please do get in touch with any of us at the Midrise program, and we'll send them through to you, of course. So
there's a couple of interesting questions. One from Sarah Bond about, is there a benefit to occupants? I would say yes. Certainly in terms of comfort and wellness, if not anything else, that's a big plus.
Yeah, absolutely.
For the same specification, for the same cost of construction, a timber-based building will offer definitely a better acoustic, a better thermal performance, perceived. The calculations may be the same from an engineering point of view, but what you perceive, believe me, I've been measuring and feeling and asking this to many people over many years, it feels better.
Yeah.
And then the other one from anonymous attendee below.
Yes, that's saying we're having issues with builders, we've just moved, who have never used tall timber construction over quoting. What do you recommend we do to source builders with the requisite skills and experience?
Can I just jump in there, Lawrence? So I saw that one. I thought that was very interesting as well. And you know, now might not be the time to talk about those builders that you should go to, but certainly contact the team and we can talk. But it's not just builders. And this is why engaging with the MAP team early in the piece, you know, during procurement and scoping of the project, to understand, you know, who are the engineers who've worked with timber, what about QS, what, you know, all of those different players in that space. It's really good to ask those questions up front, because if they haven't worked with it, they don't quite understand it, then they may overprice it. And we're finding that as well. So one of the team might want to add to that.
Yeah, that's a very good point.
It's quite normal to overquote when you don't understand the risk. You put a risk factor onto your quote. So start with having a look at our guide 51 to understand the concept of risk management, and then call us when you have a project. We are more than happy to sit together with your builder or builders of choice, go through them through the de-risking process and procurement process and make them comfortable. We have been doing this for 4.5 years successfully, so we keep on doing it.
Yeah, absolutely. So I suppose that there is a question here, which we can, of course, discuss with, well, if it's an anonymous question, so if the person would like to get in touch with us, we can discuss them in more detail around the use of timber in key external applications like balconies. Now, I think even last week, or it might have been the week before, we actually had a webinar on the use of timber externally. So that's probably the first cue. Go and have a look at the webinar from last week or the week before. But are there any sort of key suggestions which the team might have to do with particularly this context of social housing and the use of timber in external applications?
Yeah, with regards to the balconies, obviously waterproofing is the key item there. And Jennifer mentioned the demonstration building that we have at Homesland TAFE, and that has examples of how waterproofing can be applied. Again, there's technical design guides that you can download that has that information available as well.
Yeah, absolutely. And there's probably a number of examples of balconies where it has been used, whether it be just multi-residential or social housing, quite successfully. So it's obviously not some big mystery area. You just need to look at those precedents, which of course we can assist with. Look, we're running out of time, but I think we'll touch on one more question before wrapping up. It'd have to be the last question, which has the most upvotes from Jane again. Thank you, Jane. Can timber framing achieve the acoustic and fire ratings required for multi-residential structures, and if so, how?
Yeah, certainly. Paolo mentioned the deemed to satisfy requirements in his presentation. Technical design guide number 37 is specifically for mid-rise apartments, and it has details in there on how the fire rating, how the acoustics can be achieved, and they do go hand in hand. To get the fire rating, you need fire-rated plasterboard to be covering it for a deemed to satisfy solution. If you're going to have exposed timber, it then becomes a performance solution. But then going down the deemed to satisfy, that fire-rated plasterboard also comes into the acoustics. In the cavities, I think Paolo mentioned before that you have some insulation in the cavities themselves, but certainly there are a lot of systems that can be used.
Yeah, and just to conclude on this, Jennifer showed the DHHS building in Preston, and she has on her background that you can see the green in Parkville during construction. They are all light frame buildings. We sent Marshall Day to do acoustic measurements after they were delivered and they were in use by the occupants, and the measurement exceeded the code requirements. So in both cases. So look, with a good design, with a good execution, especially for the penetrations, which are always the tricky part for acoustic, then there is no problem at all.
Beautiful. Great. Oh, well, thank you very much, Paolo, Jennifer, and Dean. 3 great presentations and a very informative Q&A process. So we'll wrap up the actual presentation there for all attendees. If you do have any questions, of course, you know who to contact now, and please do feel free to leave any comments or message of appreciation in the chat. So we might just keep moving just with the sort of final closing points for the webinar. In case you're not aware of it, WoodSolutions does have a number of great resources which you can of course access for free, ranging from our Timber Talks podcast, where we've had some quite significant names from the world of property and development around the world join us. One of which is actually going to be our presenter next week. I'll let you guess which one, and we can confirm it in a couple of slides. How's that for a cliffhanger? We've got this YouTube series, which I'm a little bit biased towards because, of course, I produce it. So it's looking in the background of the timber industry. So you can see how products are made, how to design for timber solutions and timber systems effectively. And it's just supposed to be a relatively light-hearted, I suppose, look at the timber products we're learning about. One last reminder, so our attendance certificate will be issued within the next week or so. Make sure to fill it out with your details, and you can submit it to your association when you claim your CPD. So that will be winging its way across to you in the next couple of days. Now, next week, here we go, there's the big reveal. We are really fortunate to be joined by Carla Fraser, who was, I believe, the project manager. She might have been even more senior than that, but I'll say project manager. I hope I don't get in trouble. Of the building in those photos right there, Brock Commons, which is still the tallest multi-residential project in the world at 17 stories in timber, I should say. And she'll be talking about the successful project planning of MAP timber projects, which was a key factor in how they achieved their 3-day floor cycle on this project that you can see here. Really, really impressive building. So with that all said and done, thank you very much for joining us today, everyone. It's been a pleasure to have you attend, and a pleasure to, of course, have Paolo, Jennifer and Dean to present. And we look forward to seeing you next week. Thank you very much.